Well, thanks everyone. Good afternoon and welcome to BLDUP, live from the BLDUP podcast studio in Boca Raton, Florida. My name is Alex Argento and I'll be your host for today's discussion with General Insulation. General Insulation is a national company providing a full line of sustainable products and solutions for the built environment, including thermal efficiency, condensation, moisture control, and life safety, representing many of the best manufacturers and building solutions on the market today. We will discuss energy efficiency trends and opportunities insulation provides in new and existing buildings today. We will present on the use of an insulation calculator to estimate heat loss, economic savings, and environmental impact of various insulation materials and thicknesses in your building. We'll also go beyond the installed product performance and explore how manufacturers are evolving their materials, formulations, and product processes to meet today's sustainability goals. Today, we're very happy to have Frank Granara II, Regional Vice President of General Insulation, with us.
Thank you, Alex. Very happy to be here.
All right. Thanks for coming. And just to get some of the housekeeping out of the way, BLDUP presentations are intended to inform, spark curiosity, and connect the BLDUP community with industry professionals like Frank on a wide variety of topics to build relationships. They are not meant to be sales pitches. We encourage your questions and hope is that we have sparked an honest discussion amongst commercial real estate professionals and you will continue those discussions after the presentation. Today's format is always pretty straightforward. About 30 minutes of the presentation. We'll leave 10 to 15 for Q&A. Feel free to use the chat to drop your questions in if you have any. The presentation will be recorded and posted to the BLDUP and General Insulation website, so you can rewatch it to your heart's desire. And all of General Insulation's team's contact information will be made available at the end of the presentation. So with the housekeeping complete, let's closer to the build and kick off this build off view. Frank, a million thanks for being here today. I'm actually really excited about this one. And it really gets us much, much closer to our contractor and specifier friends watching. So really excited. Why don't you tell us a little bit about General Insulation to kick us off?
Yes, thanks so much, Alex. It's not every day the insulation guy gets invited to talk to such a diverse community of construction professionals. So we were very happy to be connected with you. And I got to learn that Alex is a little bit of an insulation nerd himself. So we've had some good conversations. So we're going to keep this high level today. Federally, as well as locally, we've got some very lofty goals for carbon emission reduction. And we're not going to get there if we don't fix the way our buildings are being built as well as renovated today. Right. So before we get into some of the building codes, we're going to keep it all very high level. You do not need to be a contractor to get value out of today. And I wanted to start with a little introduction about myself as well as who General Insulation is, so we can all understand what we're talking about here today. I'm the Regional Vice President, General Insulation in our Northeast Territory. That encompasses 8 locations, starting from Maine as the northernmost down to the Philadelphia market. I get to cover several different states, get to see different building codes, and that's one of the things I love about my job, getting to see the way that it's all evolving. So while General Insulation is today a coast-to-coast company, we have 50 locations across the United States. We started as one location here in Boston. We're still a family company today. We started just selling mechanical insulation. As that market matured, we evolved with it. There was a need for distribution nationally for those products. We helped bring them to market. As the need for weatherization and retrofitting in homes became more popular, we evolved with that as well. And now we're a mass save partner helping contractors every day in this market weatherize homes. As the need for commercial building envelope solutions arose, codes got more stringent. We evolved with our vendors as well to be able to offer some of those solutions. So the vendors I have pictured here today, while they are certainly 4 of our largest vendors, they're here because they're all making initiatives to be more sustainable, whether that means the way they're formulating their products or the way they're manufacturing their products or just the solutions they're offering on the built environment. So our next slide, I have an example of kind of what we're talking about, how high performance building products is a little different than what you might normally see in terms of the construction process, right? Typically, you have a specification. There's a few items listed on there. There might be some or equals allowed, and the contractor primarily is going to want to choose one of those products because it makes life simple, right? You submit on what the specification is calling for, everything goes through, and you get to start your job. But that isn't necessarily the easiest way to provide new, innovative, high-performance products onto a site. So what I have pictured here is our 3M Air and Vapor Barrier 3015. 3M came out with a very innovative product. It was thinner than a lot of products. And as you can see on the second bullet point, it has a proprietary acrylic adhesive. What that means is you don't need a primer. You can skip a whole step for a contractor, right? But that's great. It still needs to get approved, right? So we have a contractor who says, I see value in this product. It's not part of the specification, and it's technically not an equal because it's thinner than another product, right? So this is the New York Airport, which actually just won an award for the American Society of Civil Engineers Project of the Year. It was obviously a publicly funded project by the Port Authority. There is no way the Port Authority is going to allow an untested product on their site that they've never had before, right? Especially on a wall. They cannot afford for that to fail. I believe Alex gave me a stat that over 75% of insurance claims on a building is water intrusion. It simply has to work, right? So what we did was we worked with our contractor who had a product he wanted to use. We got the whole wall assembly together. So that required us to work with Rockwool as well as with 3M, with the contractor, do testing on this whole wall assembly and allow it to be approved. And so it touched every part of this construction process. It wasn't just a subcontractor. It moved from the subcontractor to the GC to the specifier to the Port Authority. And it's a great example what we're going to talk about today of that is the kind of integrated connective tissue supply chain that we're going to need to get more high performance building products into the marketplace. So let's move on to the next slide, please.
And Frank, I think the key to that is, to interrupt for a second, is that this challenge that the industry is being presented with today is increasingly stringent energy code performance requirements where products, specifiers, manufacturers, installers, the whole team really needs to understand what's going to be delivered to meet these very, very lofty and stringent energy code requirements. So just to set the table for folks, I think that that's really important to keep in mind here. And what General Installation's able to do is provide folks with those data points needed to meet those more stringent requirements. I actually was laughing, and Frank, I definitely wanted to get this in where there's a 2009 then President Obama speech at a Home Depot. And he uses the quote, "Insulation is sexy stuff." Today, we're going to show people that insulation can be sexy stuff. So let's keep rolling.
We've been waiting a long time for it to be sexy. I think Obama might have been a little early on that, but it is getting more and more important. And so I had this image on here. This was shared last week on LinkedIn by Rockwool's head of sustainability, Todd Kimmel. I loved it. I thought it was a perfect example of what building to code and building above code really looks like. So this was on the streets of New York City, done by the Pratt Institute, called the Icebox Challenge. What you can see is two identical boxes. The orange one is built to a New York City energy code, which is certainly by no means lacking in terms of energy codes. And then the green one is built to a passive house standard. If you look on the sidewalk there, you're going to see a lot of water dripping out of that orange box. That's the energy code, New York City energy code box. You look up at the green one, you see no water. This is a great example, right? You're in a home, you're built to a passive house standard. The need to cool or heat that house is significantly reduced. And so I was going to use this slide here to try to make a compelling argument for the need to kind of build above code. But the code is catching up very quickly, quicker than I realized. I actually saw an article that was posted this month on a Green Building Advisor that's on the next slide, please. That shows that Boston actually just accepted a specialized code above a stretch code, which is going to make it a leader in U.S. cities for decarbonizing CO2, thanks to its new code that is calling for any multifamily building over 12,000 square feet must achieve pre-certification passive house standards. That is huge. That's what I just showed you on the last slide. That is going to be a big change. So what is passive house standards? For those of us who might not know, we'll talk about it on the next slide. Passive house is not just about adding insulation. While there may be some more insulation on the wall, there may be insulation on the exterior wall. It's really all about the continuous insulation. It's all about those gaps, those cracks, those missing leaks of energy leak, right? So you have continuous insulation, you have air tightness, you have high performance windows and doors, and then you have the elimination of thermal bridges. While doing that, you're able to minimize the mechanical systems for heating and cooling. By how much? You can see the quote below. It's about a 60% less energy than baseline if you're building to this standard. This is a huge impact just by being deliberate about sealing up your house or your building properly. And why I say building is, if we move to the next slide, you're going to see that passive house is a deceptive term. Passive house is not just for residential building. We are actually home here in Boston to the world's largest passive house office tower. It is 800,000 square feet and is built to the same passive house standard as a residential home. They are able to achieve 65% less energy, 30 to 50% more fresh air in this office building due to this standard. I thought that was amazingly innovative. And I have a quote here from one of the architects, Blake Middleton from Handel Architects, who says, "It's never been done before, but in a few years, all buildings will have this level of performance." And I think that's a really important point, is it's done right now. We proved it could be done, and it's going to be continuously asked to be done, right? So next we're going to move to...
And I think,
Yes,
Frank,
please.
to that point, which is really impactful, is that when Millennium Partners came on many years ago now to talk about Winthrop Center and Passive House and what that meant, they were cutting edge. They wanted to be first. The slide before, what you showed was starting January 1, 2024, the Massachusetts Building Code is going to require almost passive house level of performance criteria for single family and multifamily homes in offices going forward. As a team member for a project, this is something that I'm assuming you're going to be able to help people specify correctly.
Absolutely. Thank you. And I think I actually, yes, I forgot that date, right? This passed, normally, it comes and you're going to see an energy code come out, 3 years down the line, right? The date on that was January 2024. This is coming really quickly, right? So one of the things that we try to do here is make sure that we're actually using BLDUP as well as some other resources to be able to identify specifications, codes that are upcoming, changes, get that information out to our contractor up front so we can say, this project's going to require XYZ. We have some products that will fit that environment for you and help them through that process. So the next slide is going to take us a little bit beyond the R value here. So we're talking about performance with passive house. Now we're going to move into some LEED changes. So LEED just came out with a new version 4.1, and this is, while it can perform great on a project, it also now needs to be sustainable. It needs to be, the projects need to have an environmental product declaration form that they need to submit to get LEED credits. So what does that mean? I have a good image on the next slide that gives a great visual of what we're really looking for these in product EPD forms for a LEED building. So this is an image from our vendor, Green Fiber, who makes a cellulose product. You can see at the very top of the image here that you have a tree that would either be cut or fall down in the environment and it releases CO2. So that tree is taken, is turned into paper. And same thing, you have an option here to throw it in landfill and let it produce some CO2, or you can revert it to a recycling center and turn this into insulation, which is what Green Fiber is doing and removing carbon out of the atmosphere. Now, once this product is being produced, you can see in the purple balloon that Green Fiber is choosing to manufacture their product using electricity, which is contributing to 13 times less energy used than another energy source, right? Now, not only that, but they also are manufacturing regionally, so that also reduces the need to transport. This is all part of that EPD life cycle that people are going to be looking for these LEED projects. This is a lot of stuff to take in, right? I'm sure a lot of you who might be specifiers or even owners are saying, how am I supposed to possibly pick a product if I'm being asked to go through all these different steps? And I would say that traditionally, it was not possible. That's why you didn't see this kind of stuff happening. You had products that were taking this step and simply were not getting it specified on more projects because the performance was the same. That was all that mattered. Now, I think we do have some different solutions, which I want to get into. I would like to also point out, though, that you're seeing every large general contractor hire sustainability managers, right? Sustainability managers are a very popular position right now for a general contractor. You don't see sustainability managers for a subcontractor. The subcontractors are also being asked to filter through this information. They are being asked to now select a product that they can't just submit something that has the same performance. It needs to also meet some LEED requirements, right? It needs to be produced sustainably. The subcontractors do not have the personnel to be able to go through that stuff. That's why we're trying to make this simple for the subcontractor. We're trying to help them upfront, give them this type of information so that their jobs can run smoothly. So if we go to the next slide, I want to show you a great resource. I think as we move into this beyond our value, choosing sustainably responsible products, several of our manufacturers are on this catalog called Transparency Catalog by Sustainable Minds. I believe this company is also right here locally in Cambridge. And what they've done is create a database for all of these EPDs, HPD products that you're going to need to be able to get these LEED requirements. So you can get on this database, and if you see the very top left arrow, that you can filter this by specification number, right? So right here, we're in section 23, which is the HVAC section, 07 is the installation. So you can get right down to the specification division that you need. And then you can search, you can filter by a couple things. So I have the second arrow on the left as the rating system, which would be, you can filter this by LEED 4.1. The third arrow is the one we actually filtered in this example. This one's really interesting. This actually allows you to filter for these products by a certain percentile that this product is known to be reducing carbon emissions. So if you're looking at 20 percentile, they are the top 20 percentile in reducing carbon emissions in their whole life cycle of their product. You can see our product right there, Manson Insulation, as an Acoustaliner. It has that 20th percentile. So this makes it really simple to go through and be able to say, I do want to build a sustainable building. Let me find a way to identify some products that I'm going to maybe make as a basis of design, not have just simply performance, but these products are making a more sustainable solution.
So just to drill down on that for a second,
please.
Frank, just so we can give the audience a second to digest, is in the slide before you talked about the fabrication of the material from the manufacturer, starting from its ingredients being sustainable to its manufacturing process being sustainable to trying to have a delivery and a geographic reach that meets the LEED qualifications for a project. This
Very
is
well said. Yes.
This is sort of the minimum sort of like this is we're not replacing LEDs in buildings anymore. We're beyond that. This is the minimum stuff. But I think that a point that's important for you for us to state is that the sub-market today, the subcontractor market, doesn't have to go find those things in hope that they're one-off. These actually exist. These are tried and true national manufacturers, big companies that have these products. And couple that with your tool, you're able to marry them together. So once they're ready to submit to that contractor sustainability manager, they're either meeting or exceeding the spec that was asked of them.
That's exactly right. And that's exactly the role we're looking to play here, to make that process easier, because they're going to get swarmed in paperwork if you have to start submitting all this additional paper. Absolutely.
And I think that's, really valuable to the market to sort of understand you've laid out some options here. There are some options. You could go back up through an RFI process to ask questions of the design team of what they want, but there are now options to help us get there that are, I would say, not so bespoke or custom as they may have been 7, 8, 10 years ago.
Completely agree. Yes, without tools like this, I don't think it could be done. Right? You need to be able to filter all this information, and you need partners who are going to help you do it.
And I think that goes to some of, the politics we hear often about the government or regulations or regulators asking for things that are way over the top or too complicated or too hard. Again, I'm not saying this is easy. I'm saying this is a very definable and identifiable process that your customers can go through to deliver at the highest level of sustainability for that project's requirements.
Agree. Yes, it's definitely not going to be business as usual, right? Where you could have your submittal package just on a folder in your computer and run it for everything, right? It's going to require definitely some customization there, but I do believe that it is very doable and it's going to be required if we're ever going to hit these, these energy, goals that we have, right?
Excellent. Sorry,
Great.
let's keep going.
Oh, great. I appreciate you pointing that out. So this is a great example of what we're talking about here with a manufacturer. So this is our Manson insulation, which is it's our mechanical insulation line that we sell nationally. They are using ECOS technology, which is a proprietary blend that instead of using traditionally formaldehyde petroleum products, they're using a plant-based product in their binder. So their number 3 products that you're going to see in a Manson ECOS fiberglass product is going to be 1, recycled glass, 2, sand, and 3, a plant-based binder. I mean, it doesn't get more sustainable than that, right? You don't see this as a basis of design in many buildings. I've often asked myself, why, right? There's no price premium to be able to choose a fiberglass that has a plant-based binder instead of using formaldehyde. And I think one of the common answers that I get is just mechanical insulation. It doesn't actually, it's not a big enough, it's 1-2% of the total building cost. Why would we spend our time on that kind of stuff? Well, when you start looking at this whole life cycle, it starts to matter, right? So this change was the equivalent of 100,000 barrels of oil per year eliminated by Manson manufacturing process, right? That's pretty amazing. And now we can actually measure that kind of stuff, right? With some of these tools that we've been talking about. So next, I wanted to move a little bit into existing building, right? We're going to have about 80% of the buildings that are up today still going to be up there, right? So if we're just looking at new construction, we're saying we're going to build passive house standard here. We're going to reduce energy by 60%. You still have the other 80% that are going to be producing the same energy. So what I wanted to do was really talk about a couple things that you can do today in any building that's going to help you reduce energy, thereby reducing carbon emissions, saving on your energy bill. And this is a really good example. New York City passed a local law 97, which I had not seen before. Is actually it's a greenhouse gas limit, and they're going to tax you if you are producing more greenhouse gases than you're limited based on the size of your building. That's pretty amazing. So this is existing buildings are being held accountable for this. And if you were to go to New York City's accelerator website, which is about this program, you're going to see in terms of the moderate retrofits, which basically means this is the easy stuff, right? The deep energy retrofits, that's the expensive stuff. That's where you're putting a whole new facade on the building. This is something you go in today and you'll see right in the HVAC system, circled in red there, install pipe insulation. You'll see under domestic hot water, install pipe and tank insulation. These things make a difference. I think probably a lot of people on this call will say, well, really, I mean, if I really, if I re-insulate a few feet of pipe, is it really going to make a difference for my energy bill? And I'm going to get into a couple simulations that will show you, yes, it actually does make a difference. I think it would 100% behoove everybody to take an effort in this.
And I think it's important also, Frank, for us to point out there, and we won't sidetrack on local law 97, but
Good though,
because we could spend a lot of time on it. I think the point here is that there is actually a penalty, a financial bill that the cities will start sending to building owners if they don't comply. So this is something very much beyond, I think, the altruistic hopes and dreams that LEED may have started from. Now, this is going to be seen as a taxable revenue stream for cities all across America. And while New York may be leading the charge, Massachusetts is not far behind, obviously with disclosure ordinance and Berto and the like. These things are very real. So these, as you showed, that moderate intervention can have big implications in this. And this is where insulation gets sexy. So please keep going.
Great, thank you. Yeah, so this is a real calculator that we ran for one of our customers down in Georgia. And this is showing on the left-hand side, you can see some of the parameters here. This is a free calculator. You can go and you see on the bottom right, 3eplus.org. This is produced by the North American Insulation Manufacturers Association, NAMA. So it's kind of agnostic to what type of materials you're going to be using. All mechanical insulation materials are in this calculator, so you can choose what you want. So we ran for a process temperature of 225 degrees in the pipe, right, for just an average ambient temperature of about 75 degrees. And this is a 2-inch pipe. So if we move over to the right, under this simulation, you can see some of the estimates for heat loss measured in BTU per hour per foot. And on the far right, you see the efficiency that you're going to gain by adding on insulation. So that very first column shows the thickness of insulation. The first one is bare. What does bare mean? Bare means there is no insulation on that pipe whatsoever. Either it was missed, it was never insulated, or it was taking off during the life cycle of your building. I can promise you, if you're in an existing building, you have some insulation that's been taken off so people could do some pipe testing, right? That is a very common thing. So why I have circled that 1/2-inch efficiency number is if you look down these numbers, you can see that we are going to quickly get diminishing returns here, right? We go from a bare pipe to just a 1/2-inch thick of insulation, which is the thinnest insulation you can get. You're going to gain a 79% efficiency in this simulation here, right? So your heat loss is going to go from 232 BTUs per hour per foot down to about 49, and that's a 79% efficiency. You can add on more insulation. You're going to go from 79 to 86 to 89, and now all of a sudden you're up in the 90s, and you can add all the way up to 9.5 inches of insulation. You're only getting to 95.77, right? So adding on more insulation to a point doesn't really make sense anymore, right? Where I think the real value is here, especially for existing buildings, is finding those spots where you are losing all of that energy, where you have an opportunity to really get that 80% efficiency. To me, this is the mechanical version of Passive House. This is the continuous insulation system that needs to not have any gaps, cracks, holes, missing spots where you're just leaking out all that energy.
And this is an important point. If we could just go back, Garrett, thank you, to Frank, what you're showing here. So again, 1/2-inch insulation on a bare pipe gets us 79% efficiency based on this model run for these parameters. But if you really sort of looked at a 2-inch piece of insulation at 91% modeled to 9.5 inches, which is about 4% better overall. Holistically, what you're able to show here through your review is that the stuffing the cavity idea or just making it thicker doesn't get you much. And I'm assuming, without holding you to a number, that the cost between a piece of 2-inch thick insulation and 9.5-inch thick insulation is different. I'm assuming the 9.5 is more. I'm assuming the labor to install it and put it on the pipe is more. And I only got 4% at best. You know, this is a very powerful tool to show immediate return on investment.
Very well said, and you're absolutely right. So we're actually, we are seeing that a lot, is that these thicknesses seem to be, I would say, getting very large for some small diameter pipe. And what that does is it slows down that whole process. So now all of a sudden you've got to custom order this material, right? It probably comes in full box sizes. So now you got to order extra material. And there's probably very few circumstances where you could have a 1-inch pipe and somebody has actually left enough room for 4 inches of insulation to go around it, right? So it's that whole cycle is challenging. What I think you probably get a lot more value on is if you actually had someone go through and inspect the insulation, make sure it was actually that continuous system that we were talking about. And that's the real thing. The National Insulation Association, which we're a member of and many of our contractors are, they have a certified inspector program. They have a certified energy appraiser program. So you have contractors that can come in and can do this analysis for you. We can even help you out with projects. As you see here, this is a real simulation that we did, but there's also certified inspectors. And I think that if that were to become more prevalent, you're actually seeing a lot more efficiency in your building than you are by going, like you said, from 2 to 4 inches.
Excellent. Let's keep rolling.
Yes. So this is going back to, does it matter? Does mechanical insulation matter? Does putting a few feet of pipe insulation on really worth my time in terms of if I'm trying to actually reduce some carbon emissions? So this is a comparison. This was done by previous NIA president, National Insulation Association president, Dave Cox. Love this. He put this, he went to the EPA has a nice little calculator. You can go and you can plug in and get some real life look at comparisons on carbon emissions. So, great. We can save however many BTUs per hour per foot. What does that actually mean to anybody? No one actually knows those numbers off the top of your head. So he ran a calculation based on the emissions he was emitting on his pickup truck per year. And he determined that he could go plant 360 trees to offset his 1 pickup truck carbon emissions. Or he could go into a building and he could replace 136 light bulbs for high efficiency light bulbs. Or he could go and he could insulate 8 feet, just 8 feet of bare pipe, and it would be the equivalent of 360 trees or 136 light bulbs. I think that would be a really good use of anybody's time.
It's incredibly powerful.
And so the last part that I really wanted to get into here is, even if you say, great, carbon emissions, fine, but really, what's it going to look like, coming out of my pocket, right? And these are a couple examples that were posted in NIA's magazine, Insulation Outlook, that shows this is what it's going to look like in your pocket. So we had one NIA member was able to reduce their operating costs from $100,000 to $8,000 by upgrading mechanical insulation in just one of their plants. And I know a lot of you were thinking is, well, I don't have a plant to insulate, right? That number isn't realistic, right? It's not costing me $100,000. So that second box we have there is, I think, a little more realistic for a lot of people on this call. And this is another NIA member that insulated just 48 valves, strainers or fittings with 1.5-inch thick insulation. Very standard size insulation. Project probably cost them about $30,000 to do. And they had recovered that cost in under 1 year. It was 10 months, right? It was a very reasonable expense. They got it back in months, not years. There's not many retrofits that you can do where you're going to get a return on your investment in under 1 year. I thought that was pretty amazing when I read that just 48 fittings, not even talking, feet of pipe insulation, just 48 fittings. And lastly, there's this quote from the Department of Energy that has indicated that insulation is the most cost-effective way to reduce energy consumption in buildings, which I think is a great quote. But Alex, you and I talked about, that's true, but insulation done right. And that's a lot of things that we were trying to talk about today, right? It's not stuffing more insulation in the cavity. It's not going to 9 inches thick on pipe insulation, right? It's really about making sure that it's performing well based on how it's installed.
And I think importantly that this was something that may have been esoteric or very myopically discussed by the trades that are involved with it. Now everyone's interested in this. Architects, owners, designers, property managers, operators, everyone wants to know about what insulation I can do to get ROI. And I think what you've shown, and I love that calculator, not having seen it before we worked on the presentation, is that this is very simple, achievable, and is not some pie in the sky, green building process that's never done before. This is tried and true, been there, done that, simple stuff with immediate impact. It's just, it was really interesting to see. And I'm just
Perfectly
looking at,
said.
I'm getting the high sign. So we've gone for 36 minutes.
It feels like it's been 10 minutes.
It does. You're great at this. I wanted to just ask sort of if you could give me sort of one sort of exciting thing in before we turn it over for questions in the community about what we've talked about today, something that you could sort of tell us this is exciting coming down the road.
Yeah, normally I would say that would be a very hard topic of discussion in the insulation industry, but there is actually there's some pretty exciting stuff going on. My number one pick would be, we don't have this very often. We have a new insulation product coming to market right now. So it's called a wood fiber insulation. It's being manufactured, the first manufacturing process in the United States up in Maine. It's called Timber HP. And they revitalized a defunct paper mill up there. And what they're doing is basically taking wood chipped scraps from the lumber industry that normally just goes to waste, and they're turning that into an insulation product. So that's really kind of what we were all talking about here today, right? It's that full life cycle, right? They're finding a waste and they're turning that into a usable insulation that would otherwise reduce, would otherwise make carbon emissions, right? And now they've captured it, they're using it as insulation, and it's helping out the environment. I think a really good thing to point out on that product is cellulose has been this for a long time, as we saw in that life cycle analysis, right? The only problem is that there's not too many people reading newspapers anymore, right? So we're kind of running out of reliable raw materials for cellulose, and this is a nice evolution of that, right? It's taking the same process and bringing it up the that manufacturing process a little bit, finding that wood waste and turning it into a material that can be used on a site. So that's, if you kind of encapsulate in a nutshell what insulation can be in a full life cycle, I think that Timber HP product is really exciting.
It is, and that it's made essentially locally was really interesting as well.
Yep.
I did want to make sure that you had the opportunity to bring out sort of the idea of training, design assist, and in resource a source for resources for the community. You don't need to be a contractor to call General Insulation, right? You could be an owner, you could be an architect, you could be a MEP designer, any of the above. You guys service.
Absolutely, yes. So we kind of like to say that, we sell the materials to the subcontractor, right? Our services on the construction site of those products are free, right? We go to construction projects, we help out if there seems to be any sort of installation issue, if there's any sort of technical question, we're happy to help out. And if we can't get there, we bring our manufacturer as well. So we work very close with our manufacturer and try to make sure that we together are providing the right technical support for the whole job site. That's the plan.
Excellent. And I guess Kara will open it up to questions. If anybody has any, we'll be happy to take them and answer them now.
Yeah, I just put, if you want to put anything into the chat or raise your hand, we can take any questions for you. We can take you off of mute. So let us know if you have any questions. And we will also have this recorded and living on the website. So you will be able to share this again and again if you want, and keep insulation sexy.
We were going to find a way to get that in no matter what. And oftentimes people do, don't love the stage fright of being put on blast, but we definitely will have the ability for people to get in touch with you, be able to find you. But I think, Frank, one of the takeaways that I wanted to make sure we were really clear with people on is that intervention to existing building today in today's challenging credit markets and material and supply chain and labor issues, this is really impactful ROI. This is immediate. The idea that if you have uninsulated pipe or an insulation question or that thermal barrier question where you have air or water leakage into your building, fixing that immediately impacts where you need to go. But also the code's forcing you to get there. So you might as well start thinking about it and enjoying the savings.
Great point. And you're absolutely right. I thank you for bringing that up, because it's a really interesting opportunity that no one probably thought we would ever be afforded here, is that the commercial office space, I think it's maybe under 50% occupied right now, right? So some of this really old office space here, B, C level office space is going to need to be renovated, going to be maybe, change the use of. This is a great opportunity for us to really, retrofit those old spaces that no one probably ever saw as an opportunity a couple of years ago.
I think that's really great. I guess we got a question. Is workforce up to the projected new workload? Are there people out there that can do this type of work, or is it hard to find vendors?
That's a great question. So are we talking, if we're talking kind of workforce in terms of contractor, or are we talking?
I think so.
Our level? Yeah.
No,
No,
contractor.
Yeah, there is no doubt. Certainly see the stats kind of coming out with with that the construction help is a challenge. There is absolutely no doubt about that. We've had a lot of conversations about that, about what do we need to do to make sure that our contractors have a good quality of labor coming in, right? So does that mean the unions need to take in, maybe take in some more people? But we do offer, with our manufacturers, we do offer trainings to try to get your new employees up to speed and help you out. So that's one way we're trying to help. But I do see a question. I don't know. I feel like almost like I paid someone to write this one about what's being done in Congress to be able to improve insulation energy efficiency. So I think hopefully we did a good job today, Alex, of showing that it's worth it, right? Well, I was at an insulation convention probably about a year ago, and we had an economist speaking to us, and he said, "Look at the numbers, right? You have a great ROI. The mechanical insulation world is not great at lobbying at the government to be able to get this stuff done." So the National Insulation Association is trying to change that. They actually just created a foundation called the Foundation for Mechanical Insulation, something else probably after that. But it's hopefully allowing them to get some federal grants and be able to do some more stuff at the Congress level so that it will be mandated. So I love that question. Thank you so much.
Well, I'm happy to say, short of lobbyists, which you're not, if our watchers and listeners in the build-up community need help, need access, and need a resource, General Insulation and Frank are there to help you. And Frank, I wanted to say thank you so much. We try to limit these to 45 minutes so people can watch them again. And I really have appreciated the learning about something so impactful in a time when finance is so top of mind. What you're offering and what you're able to do is immediate ROI. I don't think we can lose sight of that. So thank you and your team for your time, and we really appreciate it.
Yes, Alex, thank you so much, and really appreciate everybody hopping on at your level to be able to learn a little bit about this opportunity. I really do appreciate it. Thank you.
Awesome. Have a great day, everybody. We'll see you next time.
Thank you.